Laws of exponents. There are a bunch of different rules to tell us what we should do when there's exponents and other operations. So let's get to it. The different things that we're going to cover in this video and on the test are product rule, power rule, quotient rule, negative and zero exponent rules, and scientific notation. So this is the first one. This is product rule. Product is just multiplying things. So when you're multiplying and you have a variable, when you have an exponent, you are going to think about this as this is the same thing as x times x. This is the same thing as x. This is the same thing as x times x times x. And since there's a times sign here, I could write this out the long way and say this is x times x times x times x times x times x. But to shorten it up, I can just count all of these and say this is the same thing as x to the 6th power. Now what you may notice is that this x is to the 2nd power. This x is to the hidden 1st power. Whenever you don't see one, it's to the 1st power. And this one's to the 3rd power. And when you add those powers all together, you get the 6 that you see here. So it's no surprise that the rule for multiplying exponents is to add the exponent. It's interesting how when you are doing exponents, everything seems to be like one step below what you would do. So for example, multiplying is really repeated addition, right? Well, when you're multiplying exponent, you add. Next, we're going to find the power rule, and the power rule is saying when you're taking an exponent to a power, you're going to multiply. So you're kind of taking it back a step, and powers are repeated multiplication. That's kind of how I remember these without remembering the rules. Let's go on and do some harder examples. So product rule again. Here we can see that this would be like negative 2 times x times y times 3 times x times y times y times y. And if I wanted to, because multiplication can happen in any order, I could rearrange these things and I could put my numbers together and say negative 2 times 3 is negative 6. And x times x times x, we could simplify that by saying x to the 3rd, and y times y times y times y is y to the 4th. But what I did was I took my number parts and I multiplied them. I took my variable parts and I added their exponents. Okay, so this was a 2, this is an exponent of 1, this is an exponent of 1, this is an exponent of 3, and that's how I got these values down here. Okay, so the basic rule for multiplying, or the product rule, is that we're going to take our number parts first and we're going to multiply the numbers. Then we're going to take our powers and we're going to add the powers. So for this one, I'm going to take 5 times 6 and I'm going to get 30. I have x to the 3rd and x to the 5th. Together, that's x to the 8th. This one, this one here, I put in because of this negative sign. I want you, whenever you see a negative, to put a 1 next to help you remember how that negative is going to work. So I'm going to take this number negative 1 and the number 3, and I'm going to multiply those. I get negative 3. And then I'm going to take my x squared, and I'm going to put those together for x to the 3rd power, my y, my y, my y, my y to the 3rd power. Okay, and the next one, again, I'm going to take all the number parts and I'm going to multiply them. I just start with the first variable that comes next. So I'm going to do my x's next, and I get x to the 3rd power. And my y's next, I have y to the 6th power. It would not be wrong if I put negative 24, y to the 6th, x to the 3rd. We do typically list our exponents in order from least to greatest, but I actually list them in order of how I see them in a problem. All right, and the next one, again, we have that invisible 1 sitting here to help me remember that that negative part goes with the numbers. So negative 1 times 2 is negative 2. D to the 9th and D to the 15th makes D to the 25th. E doesn't have any other E's, so it's just that one E, and F doesn't have any other F's, so it's just that one F. This one's different, isn't it? This is actually going to be our power rule. So we see that we have 2x to the 5th power, and then that all is taken to the 3rd power. So what that's saying is we're taking 2x to the 5th times 2x to the 5th times 2x to the 5th. So I'm taking my number part and I'm taking it to the 3rd power, right? 2 times 2 times 2 is 8. And my letter part, if we look at this, we have 5 x's here. We can picture them, right? Times 5 x's here, times 5 x's here. And if you look at all of these, we have 15 x's. So what I actually did for the exponent, just like I kind of said before, is I took these exponents and I multiplied them. So when I take a number to a power, I actually apply the power. When I take an exponent to a power, I multiply. That is our power rule. So when I take an exponent to an exponent, I'm going to multiply those exponents. Here's an example of a to the 5th power. We have a to the 5th, a to the 5th, a to the 5th. Altogether, that's a to the 15th. Let's do a harder example. Okay, so this isn't that much harder. The numbers are a little bit bigger, but we've got y to the 6th to the 20th power. So picture 20 of these sitting there. So we've got y to the 6th 20 times in a row. So I'm taking 6 times 20, which is 120. And it's y to the 120th. Glad I didn't have to write that one out to solve. The next one, I have a number part, and I'm going to take the number part to the 5th power. So this might be where your calculator becomes a little handy. I'm going to take 2 to the 5th power, which is 32. And then I'm going to take, before I take these to a power, I'm going to just go ahead and put them together because they're multiplied right now. A to the 5th power to the 5th power. So I'm going to multiply those out and I'll get a to the 25th power. And then again, for the last one, I'm going to start with my number. I'm going to take 3 to the 3rd power. And then I'm going to actually take 3 to the 3rd power, and I get 27. And then I'm going to take x squared to the power of 3, which means I'm multiplying those two. So x to the 6th power. And remember, y is just y to the 1st power, and y to the 1st power times 3 is, or to the 3rd power is going to be y to the 3rd power. Now this gets a little tricky because I did not yet show you quotient rule. You might remember quotient rule from class, but we don't need quotient rule quite yet for this problem that we're about to do. What I'm going to do is I'm going to take this power of 3 and I'm going to apply it just like I did in the other problems, but I'm going to apply it separately first, and then in the end I'm going to simplify. So I'm going to take this power of 3, and I'm going to say, okay, 6 to the power of 3, and then I'm going to take, so 216, and then I'm going to take x to the 4th to the power of 3, which is x to the 12th, and then I'm going to take y to the power of 3, y to the 3rd power. Then on the bottom, I'm going to take 9 to the power of 3, and I get 729. I'm going to take my fraction, 216 over 729, and I'm just going to simplify that. So when I simplify that, I get 8x to the 12th power, y to the 3rd over 27. So another option of what I could have done, which I probably should have done, is I could simplify this first and say, well, that's the same thing as 2/3. And I could instead take my 2/3 to the 3rd power, which would give me 8 and 27. So let's do it that way for this next one. Let's simplify the fraction part first. So I've got 1 over 2, and then a to the 4th, c. And now let's apply the 2nd power. Remember, though, I'm still applying it separately to each piece. So 1 to the 2nd power is 1. and then a to the 4th power to the 2nd power is a to the 8th, c to the 2nd power, all over 2 to the 2nd power, which is 4. Okay, and the last one, because I've got parentheses and I have brackets, these parentheses say do this first, and then this, and then the outer brackets. So the very last thing I should be doing here is the exponent of 9. So what I'm going to do is on the inside here, I'm going to multiply out my w to the 5th, x to the 2nd times w to the 2nd, x to the 4th. So I'm just going to add those exponents first. Then I'm going to take it to the 9th power, which multiplies these out. So I've got w to the 63rd and x to the 54th. Yikes, those are big numbers. Now we're ready for quotient rule. Quotient rule is where we've got a division problem. So here I've got z to the 2nd power, and I'm going to draw it out like I've done in some of the other problems. Z to the 2nd power is the same as z times z. And z to the 5th power is the same as z times z times z times z times z. Okay? Whenever I have the same number or letter on the top and the bottom, I can cancel them out. So those cancel, these cancel. We never leave the top completely empty though. So we wouldn't have a fraction that looks like this, z to the 3rd, and just be done. Okay? What we're going to do is we're going to put a number 1 on the top, because technically this could have been 1z times z. And so 1 is going to remain on the top so that we know that it's still a fraction, or it's still thinking like divided by z to the 3rd. Notice how I took these 2 z's and these 5 z's and I canceled them, and I'm finding the difference between the top and the bottom. So notice I'm finding that the space between these is 3, and there's the 3 that remain are on the bottom because this number was bigger than this number. So the quotient rule, I should go back. Quotient rule says that I'm going to take the top minus the bottom. Now, I don't always do that exactly. I think about it a little bit differently, but yes, we're going to take the top minus the bottom. Sometimes when we do that, we'll end up with a negative number. We haven't done negatives in this video yet, but we have done negatives in class. Negative exponents, if they're found on the top, need to move to the bottom of the fraction. If they're found on the bottom, need to move to the top. That gets a little bit tricky. So right now, I'm just thinking about where would my excess be? When I subtract, where would my leftovers be? Would they be on the top or would they be in the bottom of the fraction? So here you can see we've got 5a to the 5th on the top and a to the 3rd on the bottom. So when you cancel these out, you've got 2 a's left on the top. Now, if they're on the top, it's over 1, and anything over 1, that 1 can just disappear. So that's my answer. Here we have the opposite, and we've got our 2 a's on the bottom, and so they show that we put 1 over the top. All right, so same thing here. I'm going to find the difference on the top and the bottom, and I'm going to decide, okay, the difference here is 2, right? So the difference between 5 and 3, or when I subtract the big number minus the small number, I get 2. Where are those extra 2 when I cross off? They're going to be on the top. So a to the 2nd power is going to be on the top. Now here I have 6 is the difference, but there's more b's on the bottom, so that's where the excess is going to be. This b to the 6th will go on the bottom. And here you have an excess of 1. That extra c is on the bottom. So it looks like that. It's kind of a sloppy fraction, but there it is. Okay, let's do this next one. Now we haven't had a number yet. When there are numbers, well, I guess we sort of did earlier before we did quotient rule. When we have numbers, we're going to simplify those numbers, or we are going to divide. But in this case, if it doesn't divide out to be a whole number, we're going to actually leave it as a fraction. So a negative divided by a negative is a positive. So these negatives can cancel out. And 3 and 18, we can take a 3 out of both of those and call it 1/6. I don't technically need the 1 to show on the top unless unless the top ends up being blank. Now, if I put a 1 on the top, it's not wrong. It just doesn't need to be there, so I'm not going to put it there. Now here, again, I have a difference of 2. Those 2 A's are on the top. Here I have a difference of 4. Those 4 B's are on the bottom. And here, they're the exact same. They're going to cancel out, and there will no longer be C's in this problem. Done. So there I could have that, or I could still have that 1 on the top. Let's do some more. So on this one, when I divide, 10 divided by 2 equals 5. That 5 will be on the top. Think about it as like 5 over 1. This cancels, and this cancels. So if I have a 5 and it's on the top, I don't need a bottom. I'm done. This next one, I have negative 5 over 20. So that's going to simplify to be negative 1/4, or I can just say negative on the top and 4 on the bottom. These r's, when I take the difference, I have an excess of 7 on the bottom, r to the 7th. And when I take the difference here, remember this is a 1, I have p to the 3rd on the top. Okay, the next one, 18 divided by 6 is 3. That's going to go on the top. I don't need a number on the bottom. M to the 5th minus m to the 2nd is m to the 3rd on the top. And n, I have an excess of 8 on the top. And then this p to the 3rd is going to stay on the bottom because there's no letter p on the top. All right, and the last one doesn't have any numbers. That makes it easier. I'm going to subtract this. Remember, that's a 1. So I have 1x on the top. I'm going to subtract this, and that's 1y on the top. So this simplifies to be xy. All right, this should be easy. When you end up with a power of 0, the answer is always 1. So that's the rule. When you have anything to the 0 power, the answer is 1. Notice that 5 minus 5, you'd have an excess of 0, or they just cancel each other out, which equals 1. 3 to the 0 equals 1. 5x to the 0 equals 1. Now this negative, because it's out front, will stay on there. Okay, again, 8x to the 5th y to the 0. This whole thing equals 1, but this part out front still remains negative 3 times 1, so the answer is negative 3. Now down here, anything to the first power is itself, so that's another rule. So 3x to the first power is just 3x. xy to the first power is just xy. 14x to the 5th power to the first power is just 14x to the 5th power. Now let's move on to negative exponents. So a negative exponent is the same as the reciprocal of that exponent. So notice if it has a negative sign, I'm going to make it positive and move it to the bottom of the fraction. If it was negative on the top of the fraction, for example, this part here, it's going to move to the bottom of the fraction. That's why we're thinking reciprocals and not just going to the bottom, because bottoms can move to the top, tops can move to the bottom. So here we've got our y to the negative 7th. That moves to the top. This is, I think, the easiest to just see it happen. But as you can see here, they took a number and they did the reciprocal of that number and they got rid of the negative. So for the first one, let's talk about just kind of almost proving this. So if I took 2 to the 3rd power, let's say, so I know it says 2 to the negative 3rd, but let's say I took 2 to the 3rd power. That's 2 times 2 times 2, which is 8. If I took 2 to the 2nd power, that's 2 times 2, which is 4. 2 to the 1st power, anything to itself, the first power is itself. 2 to the 0 power, anything to the 0 power is 1. We notice that there is a pattern. I'm dividing by 2, dividing by 2, dividing by 2. So it's logical that the next thing I do when I get to 2 to the negative first is to divide by 2. So I have 1/2. If I have 2 to the negative 2nd, I'm dividing by 2 again, which gives me 1/4. And if I do divide by 2 again, oops, that should be negative 3, I have 1 over 8. So in other words, what I'm doing when it's a negative is I'm taking this 2 to the third power as a positive, and I'm putting it over 1. 2 to the third power as a positive is the same as 1 to the 8th. So here we go. On this one, I see a negative power on the bottom. I'm just going to move that negative power to the top and make it a positive power. 2y to the 7th. If it is a fraction with numbers, you're going to take that fraction and you are going to write it as its reciprocal, and you're going to change the power to a positive. Then simplify if you can. I noticed that 4 to the second power is 16, and I don't need to put it over 1, even though I could do it over 1. Okay, whenever we just have variables, we're just moving things if they are negative. So I'm going to change all my negatives. I'm going to move my a to the negative 2 to the top. So I've got a to the 10th, a to the second, and put them together. I have a to the 12th. Here the m to the third is going to the bottom and the m to the 8th is going to the top. So I'm basically just writing this reciprocal, m to the 8th, m to the third with positive values. Okay? This gets a little bit tricky. Then right now I'm going to be leaving this as a fraction unless it all simplifies to be on one side. But I'm going to take my number part and I'm going to apply this fraction bar or the quotient rule here. So I'm just going to simplify that. 1/2. I was just double checking to make sure that the numbers weren't to a power, and they're not. Okay, then I'm going to take this a to the negative 5th, and I'm moving it up to the top. So when I do that, now how many a's are on the top? There's 7. Okay, and I'm going to move this b to the negative 4th to the bottom, and this b to the negative 10th to the top. That is how I get rid of their negatives. I switch them to their reciprocal, or to the opposite side of the fraction bar. I'm going to do the same thing again. I'm going to take the x's and I'm flip-flopping them because they're both negatives, and I'm going to make them both positives, x to the third. Same with the y's. I'm going to take this y to the 5th back to the top and y to the 2nd to the bottom. Okay, now that I've done that, oops, and I didn't even realize, as you can hear, my phone went off telling me it's time for bed, and I can see that it must be because I forgot to simplify this. If I was doing quotient rule, I would look at this and I'd say, I'm not done. So I am not done now either. I'm going to take these two b's and I'm going to find the difference. The difference is 6, and where does that difference go? On the top. So I'm gonna go ahead and not write that 1. So I've got a to the 7th, b to the 6th on the top, and now I have just 2 on the bottom. Okay, so for this other one, I noticed that these have a difference of 9. X to the 9th is on the top, and y to the 3rd is also on the top, and that doesn't need anything on the bottom then. Yay, we're almost done. Scientific notation. Scientific notation is a way that scientists use to write big numbers by writing it times 10 to the power of something. They fit into this unit because we have exponents going on with that power of 10. So what I'm going to do is I'm going to think about where my decimal point is. If I don't see it, it's at the end of the number. And I'm going to move it so that it has one digit and then a decimal point. So I'm going all the way until there's one digit that's a non-zero digit and then a decimal point. In other words, this is going to be a number somewhere between 1 and 9.999999999, right? Okay, so I'm going to do that, and as I do that, I'm going to count how many places I move the decimal point. So I'm moving it to here, right? Because that's the first place I can get to that has only one digit in front. So I'm going to count from the back. 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm going to write these digits. Oops. I'm going to write, I got this. Here we go. I'm going to write these digits, 3.3. Then I'm going to write times 10 to the 9th, because that's how many places I moved the decimal. Now, the secret is it's going to be a positive number up here, a positive exponent, if your number was super large to begin with. If your number is super tiny to begin with, it's going to be a negative exponent because you're moving it the other direction. Let's do the next one. I'm going to move the decimal point here, but right now it's starting here. So I'm going to go 1, 2, 3, 4, 5. Okay, so I'm going to write 1 times 10 to the 5th power. Done. Next one, I'm moving my decimal point here. Let's count. It's a lot. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I'm going to write 4.67 times 10 to the 11th. If these digits keep going and they're not zeros after this, you can round after you get to the hundredths place. You can round the next values. I'm not going to give you anything on your test where you need to be rounding. Okay, the next one, I'm going to move my decimal point again so that there's one digit in front. Now this time I'm going the opposite direction. I'm talking about a teeny tiny number. So I'm going to go 1, 2, 3 places, right, to get there. So I'm writing times 10 to the 3rd, but not the regular 3rd, the negative 3rd, because I'm talking about a teeny tiny number. Teeny tiny numbers get negative exponents. Let's do this again. I'm moving to here. 1, 2, 3, 4, 5, 6, 7. 5 times 10 to the negative 7th. And to here. 1, 2, 3, 4, 5, 6, 7. 4.15 times 10 to the negative 7th again. If I'm going back the other direction, I'm going to say this number needs to get bigger because it's a positive. It's talking about a big number. And right now it's not that big of a number. So I'm going to go make it bigger by going this way. 1, 2, 3. Those extra spaces will be filled in with zeros. Again, 5 spaces. 1, 2, 3, 4, 5, 3, 6, 1. And there's 1, 2, 3 zeros. 1, 2, 3. A lot of times people get confused and think this is telling me how many zeros. It is not. It's telling me how many places to move the decimal point. You will probably be off about 50% of the time if you're only counting zeros, maybe even more than that. So I've got this decimal point here that was hidden because you couldn't see it. Remember, there's always a hidden decimal point at the end of a whole number. So I've got 7. This time, I actually do have 7 zeros because I'm counting 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Okay, and now these ones I'm counting to make them smaller. So if I move to the right, that would make that number a lot bigger. So I need to move to the left to make it smaller. 1, 2, 3, 4. I'm running out of board here. I run into my tools when I do that, but I have a decimal point, and then I have 3 zeros, 6, 3, 2. Okay, the next one, I'm going to start at my decimal point. I'm going to move 2 to the left, 0.098. I like to start with a 0 just to make it obvious that there's a decimal point there. Okay, and then 8 places to the left. 1, 2, 3, 4, 5, 6, 7, 8. Again, I'm starting with a decimal point, or sorry, with a 0 and a decimal point. All done. Now we can do operations with scientific notation. These ones aren't really anything new, except for that we've been doing these with variables here before. So what you're going to do if you're multiplying is you're going to use product rule. You're going to take these numbers and you're going to multiply the number part. You're just multiplying them. So 4.2 times 3.6, and I get 15.12. And then instead of multiplying these out, I'm going to add the exponents. So I got times 10 to the 11th power. Okay, so if I do that again, all I'm doing is taking the decimal, 2.3 times 8.5, 8.5, and I get 19.55 times 10 to the 10th power. Okay, and the next one, 10.7 times 4 gives me 42.8. And then times 10. This one's a little bit tricky because I've got a negative and I've got a positive. But when we add those exponents, I'm still at a negative 8. Oops. Times 10 to the negative 8th. Okay. Now, I know you'd say, wait, that needs to be on the bottom of the fraction, right? When we're doing scientific notation, we don't have a top and a bottom of a fraction. We actually do use negative exponents. All right, when I do division, I'm going to use quotient rule. I'm going to divide this, but this time I actually do want to see it as a decimal. So I've got 0.25 times 10, and then when I find the difference here, I have 4, and it's a positive 4 because it's on the top. So if you solve this and you get numbers that are on the bottom, treat those as a negative exponent. Okay, so there's a problem here. This is not the form it needs to be in. Remember it had to have a non-zero digit and then the decimal point. This is not a non-zero digit. So technically, I need to make one more move this way, right? So I've got 2.5. But I just made this one little bit smaller. So I want to show that, sorry, one little bit bigger. So I want to show that by making it one move less. So technically, when I had 0.25 times 10 to the 4th, to make it its standard form, I would be moving that decimal point 4 places, correct? But if I already moved it one of the places, now I'm only going 3 places to the right. I kind of suggest when you make that adjustment that you do write it out on your test because it's a hard concept to understand. Do I go up by 1 or do I go down by 1 when I shift that decimal point? 2 more examples and then we are done. So I'm going to take 9.2 divided by 5. I get 1.84. That's good because it's a non-zero digit and then a decimal point. Times 10. This time I have 6 on the bottom. So if 6 is on the bottom of the fraction and I'm writing it without a fraction, I'm going to write it as a negative 6. Okay, and the last one, 4 divided by 1.6. I get 2.5. That also worked in my favor. It's got a non-zero digit to begin with. Now this one's really tricky. I could use the rule like the top minus the bottom, but what I kind of like to do is just switch them around to where they belong if I was just going to move them. And now I'm going to make that adjustment. I'm going to say, okay, there's a difference of 5, and the 5 is on the bottom, so I'm going to say times 10 to the negative 5th. All right, it was a super long video. I hope that you got a lot out of this. Good luck on your test.